last session, okay, of the very first session. Okay, the last session was very first session, and in that I have told you the content which we will covering, okay, throughout the lab course. Okay, I told you about this everything: scheme, what are the outcomes, what is the list of experiments, case studies, okay, virtual labs, all those. Okay, now let us start with very first experiment. Okay, and that is study and performance of simple vapor compression test rig. Okay, experiment number 1, that is study and performance of simple vapor compression test rig. Okay, so this is a practical, okay, which will perform in the today's session. Okay, so we will perform the practical. Okay, we will just take the reading, and if time permits, we will also proceed with the calculations. Okay, we will also proceed with the calculations. Okay, so let us start with this experiment. Okay, study and performance of simple vapor compression test rig. Okay, so this is a practical, okay, which will be performing. Okay, so now I will start with the board. Okay. Okay, so see here all of you now. Camera is on. Okay, so here we will start with the simple compression test rig. A simple compression test rig. Okay, now what is that simple compression test rig? Are you able to hear me properly? Yes? Can you hear me properly?
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
So see, we are starting with the first experiment. Okay, that is experiment number 1. Experiment number 1. Okay, and which was that? It is simple vapor, okay, compression.
This is not visible.
Vapor compression system. Simple vapor compression system. Right? That we are going to see now. Right? Now see all of you here. Okay. So in simple vapor compression system, what we have?
Keep it horizontal.
We have a compressor. Okay, so I'll just draw the diagram for the compressor. Okay. So this is a compressor, as you can see. Okay. So for compressor,
सर बुक पेन पे पढ़ाओ ना, इससे दिख रहा नहीं.
there will be some outlet.
Sir, blur हो रहा है पूरा. Sir, keep it horizontal, sir.
Yeah. Can you see now?
Yes, yes, it is visible.
Okay. So see, this is a compressor. All of it. This is a compressor. So we are starting with the compressor basically. Okay. So this is inlet to the compressor, right? This is outlet to the compressor. Okay, we have a compressor. We have a compressor where the one is the inlet to the compressor and 2 is the outlet to the compressor. Okay, so fluid. Okay, the fluid will be get compressed. Okay. Now see, once it is going to get out of the compressor, okay, what we will do is we will supply it to the condenser. Okay, we will supply it to the condenser. Okay, so see, one is the inlet to the compressor. Okay, 2 is the outlet to the compressor. Okay, so once it is getting out of the compressor, we will supply it to the condenser. Okay, now once it is getting out of the condenser, see, 2 is the inlet to the condenser, 3 is the outlet to the condenser. What we will do here is, okay, we will supply it to the expansion device. Okay, I'll just mark a diagram here. Okay, we will supply it to the expansion device. Expansion device. Okay, for example, capillary. We can call that as a capillary. Okay, expansion device like capillary, right? Once it is getting out of the capillary, okay, we will supply it to the evaporator. Okay, so 3 is the inlet to the capillary. Okay, so obviously, okay, 4 will be the outlet to the capillary. Okay, now what we will do here is, okay, so once it is getting out of the capillary, okay, we will supply it. Okay, see here. Once it is getting out of the capillary, okay, we will supply it to the evaporator. We will supply it to the evaporator. Okay, we will supply that to the evaporator. Okay, see, the compressor will compress from 1 to 2. Okay, the condenser, okay, will pull it from 2 to 3. Again, expansion device like capillary, okay, it is going to expand it from 3 to 4. Okay, and further, evaporator will, okay, evaporate it from 4 to 1. Okay, so as you can see, okay, this is a cycle. This is a cycle. Okay, see, the purpose of every device, okay, you know that compressor is to compress, condenser is to cool, okay, expansion device is to expand, and evaporator is to evaporate. Okay, so this is the layout of the cycle. Okay, now see, when you talk about the cycle, okay, let us start why we are studying this experiment, or what is the purpose to learn this experiment. Okay, so purpose to learn this vapor compression system, okay, is, okay, our purpose is to calculate, okay, we need to calculate, okay, coefficient of, we need to calculate coefficient of performance. Okay, we need to calculate the coefficient of performance, right? What we are supposed to calculate? We are supposed to calculate the coefficient of performance, okay, actually, okay, actually and theoretical, okay, and theoretical. Okay, we will calculate coefficient of performance actually and theoretical. Is that okay? Yes, is that okay, all of you?
Yes, sir.
Okay, now see here, all of you. See, I'm explaining, okay, very shortly. Okay, consider a compressor, okay, which will compress the fluid from 1 to 2. It will go to the condenser, which it will cool it from 2 to 3. Then it will go to the expander, okay, like capillary tube, where it will be expanded from 3 to 4. And further, it is heated to evaporator from 4 to 1. Okay, so purpose to learn this experiment is to calculate the coefficient of performance actually and theoretically. Okay, we need to compare what actual COP we are getting, okay, as well as what theoretical COP we are getting. Okay, so this is basically simple vapor compression system. This is simple vapor compression system, right? Now, okay, now what we'll do, okay, now see all of you. Now see this cycle, okay, this simple vapor compression system, as you can see, now we are in a HVAC lab. Okay, so you can see this refrigerator. Okay, refrigerator you can see. Okay, refrigerator. Can you see this refrigerator, all of you? Okay, now see.
Yes, sir. Yes, sir.
Okay, now what I done? Okay, initially I keep it switched off. Okay, now as you can see the refrigerator, let us try to locate where those components are. Okay, now I have shown you the diagram. Okay, now let us see the actual components for the refrigerator. So as you can see now, okay, all of you, okay, can you able to see this? Okay, compressor. Yes, this is a compressor. Can you see? Yes,
Yes,
this is a compressor. Right, this is a compressor. See, we have this refrigerator. Okay, this is a compressor. You might observe it in your home. This is a compressor. Okay, so
yes,
from compressor, where it goes, from compressor it goes to where? It goes to condenser, right? Yes, from compressor it goes to condenser. Now what is condenser? Now see, if you buy the fridge, okay, 10 or 15, let's say 10 years back, okay, so at the back of the refrigerator you might observe some coil like this. Okay, many of you are having those coils, right? At the back side of the refrigerator, such coils, such tubes. Okay, have you observed it at your home? Yes.
Yes, sir.
नहीं सर
Okay.
हमारी फ्रिज में नहीं है.
Yes.
Yes, sir.
So such coils are called as condenser coils. Okay, they are the condenser coils. Right? They are the condenser coils. Because see, all of you might feel some hot temperature. Okay, some hotter region. Just okay, just close to it. Okay, so when you just put a hand and if you try to locate its physical condition, okay, you might find it to be okay hot. Okay, so now see this is the latest refrigerator where the coils are inside. Okay, right? So those are the condenser coils. Okay, so after the condenser, what we have seen? We have seen the expansion device. Okay, I'm telling you, compressor. We have as I shown you. Okay, below this is a compressor, right? This is the compressor. Okay, then condenser. Okay, we'll observe such tubes at the back. Expansion device or capillary tube. Okay, you will find here somewhere here. Okay, right? Expansion device, right? This is the expansion device. Okay, and okay, after the expansion device, what happens? Yes, after the expansion device, what happens?
Evaporator.
Okay. So what happens after the expansion device? Where does it goes? See, all of you, try to see where does it goes.
Evaporator, sir.
See here, all of you, just see the diagram. After the evaporator, expansion, it goes where? To the evaporator.
Compressor sir.
Yes. Now, okay, where the evaporator is located? Where the evaporator is located?
सर इधर पे कूलर के सामने फैन के
Deep freezer.
When you see the freezer, okay, see this freezer. This is the freezer of your home. Okay, so see, this is what you used to call this as a freezer. Okay, so let us see the evaporator coils. Right, let us see the evaporator coils. Okay, let us see the evaporator. So see, I will show you the evaporator coils now. Yes. Can you see the evaporator coil now?
Yes
Can you
sir.
see the evaporator
Yes,
coil
sir.
now?
Yes sir.
Yes, sir.
Okay, so these are the evaporator coils, as you can see, right? These are the evaporator coils, right? So see, tubes, you're able to see the tubes, right? So through the tubes, what happens is the refrigerant is flowing through the tubes, right? Through the refrigerant, these coils, evaporator coils, the refrigerant flows. Okay, so what this refrigerant does, okay, what this refrigerant is doing, see, whatever the food atoms that you will keep, okay, inside this chamber, okay, so this refrigerant is going to abstract the heat from the food atom. Okay, so what are the food atoms that you will keep here? Okay, so from that the heat is being abstracted by the refrigerant. Okay, and when the refrigerant which is flowing through this tube is going to absorb the heat, okay, when it is going to absorb the heat, what will happen? It gets evaporated. It gets what? Evaporated. That is the reason why this region it is called as evaporator. Okay, see, whatever the food atoms, you keep it here. Okay, when you place any food atom here, what will happen? The refrigerant which is flowing inside this tube, okay, will abstract the heat from it. Okay, and when it will abstract the heat from it, what will happen? That refrigerant gets evaporated. Okay, because when it absorbs the heat, okay, it gets evaporated. Okay, so this is how the cycle works. Is that okay? Yes. Is that okay with this one?
Yes sir.
Okay, now see, this is all about our household refrigerator. Okay, now what we are supposed to do is we are supposed to perform the experiment. Okay, we are supposed to perform the experiment. Okay, so for performing the experiment, as you can see, okay, so this is a setup which
सर
is
ये जो
available.
कॉइल रहता है उसके पीछे कोई ब्लोअर नहीं रहता है, फैन या ब्लोअर?
No, not required. See, sometime for cooling purpose it is required. Okay, just close to the compressor. Okay, but for some time it might not be required. See, what I'm telling you is the basic part. See, add-ons you can add, not a problem. Yes. See, those are called, you can call those as accessories, right? They will not be involved, or they will not affect the cooling, rather. Yes?
Okay.
Okay. Now see, so in order to study the experiment, okay, we have this setup in our college. As you can see the setup here. Okay. So this is basically the air conditioning test rig. This is a setup which is the air conditioning set rig. Okay. Now as you can observe here, okay, let us try, or let us see the components. Okay. Initially, I've shown you the components, okay, on the board. Initially, I've shown you the components on the board, right? Now I've shown you in the refrigerator, okay? And now for the practical performance, okay, we have the setup, right? Now, why we are not performing the experiment on the refrigerator is we are not able to calculate or we are not able to measure some of the temperature and all those things. For that, okay, we have this setup here, okay? So let us start with that. Okay, let us see the first component. Can you see the first component? This one. Can anybody tell me what is this component? Yes.
Compressor.
Yes, exactly. It's a
Hermetically sealed
compressor. Yes, you can see this. This is a compressor, right? This is a compressor, right? Okay. Now see, when you can see this line, okay. See, if you see this line, okay, which is basically, okay, can you see this red line? Red line, all of you? Red line,
Yes,
red
sir.
pipe.
Yes, sir.
Okay, so this red pipe.
Grazing rod है ना sir ये?
Yes, yes. Yes, all of you. Red pipe. Yes, red pipe.
Yes,
you
sir.
can see.
Visible है.
हाँ,
Yes.
दिख रहा है तो।
As well as you can see this black insulated pipe, right? Yeah. Okay. So see, this black insulated pipe, as you can see, this is the inlet. This is the inlet to the compressor. Can you see? This is the inlet to the compressor, right? Yes. Black is the inlet to the compressor. Okay. It is from the top. Okay. What is about this red? Red is the outlet to the compressor. You can see. Red is the outlet to the compressor. Can you see that? Yes. Yes. See, you can see here. I'm at the back side now. This red part. It's the outlet to the compressor. Yes. Is that okay? See. This blue one. Sorry. This black one. You can see this black one. Black. This region. Okay. This black piping. It's the inlet to the compressor. You can see this is the inlet to the compressor. Right? Yes. Black is the inlet to the compressor. Okay. That means this is the condition 1. See here, what is the condition? It is 1. Okay, our point will be 1. 1 is the inlet to the compressor, right? Okay. Now when you talk about the red line, as you can see this red line which is coming. Okay, red pipe. Okay, it's the outlet to the compressor. Is that okay? Okay, so on this line, we will get point number 2. Is that okay or not? Let me know. Yes. Just see this diagram. Just see the setup, actual setup you see. Yes? All of you?
Yes, sir.
Okay, see here. This insulated pipe. Okay, this insulated pipe. It's the inlet to the compressor. Okay? While this red color pipe, it's the outlet to the compressor, right? So here we will get state number 1. Okay? At the outlet of the compressor, okay? At any point on this pipe, okay, we will get state number 2. At any point of this line, okay, red color line, we will get state number 2. Right. Now see, all of you. Okay, after the compressor, what we have condenser. So can you see this part? This is a condenser. Yes, you can see this. Where this red color line is connected, it is going to where? It is going to condenser. Yes. Can you see that? Yes, all of you.
Yes, sir.
Yes. Can you see that? See,
Yes, sir.
from the compressor, where it is going? To the condenser. Yes. Now see, as you can see here, one thermocouple. See here, what we are doing? We are measuring the temperature. Okay. So at the inlet to the compressor, you can see this line. This line is the inlet to the compressor. So here we are measuring the temperature. You can see this arrangement. So as to measure the temperature at the inlet to the compressor. Okay, so this will give me T1 because T1 is the temperature at the inlet to the compressor. So this, okay, this arrangement will give me the temperature at point number 1. Okay, that is at the inlet to the compressor. Okay, similarly, when you can see this is the outlet of the compressor, red line is the outlet of the compressor. Okay, so on the outlet, okay, I am measuring this temperature. Okay, so for that again I have one temperature, okay, sensor. Okay, so here I will measure the temperature. Okay, see what is the outlet to the compressor? It is nothing but inlet to the condenser. You can see outlet of the compressor is the inlet to the condenser. Okay, so in between outlet of the compressor and inlet of the condenser, okay, I will measure the temperature. Can you see this? How yes, all of you. So it will give me value of T2. Yes, all of you. Can you see this? It will give me a value of T2. Is that okay? Yes. Okay. Now see. So from compressor, this red line is red colored pipeline is going, and it is going to where? It is going to the condenser. Okay. Now see, all of you. You see here, right? See, this is the inlet to the condenser. This is the inlet to the condenser. Similarly, okay, you can see at the bottom. See, red is the inlet. Okay, at the bottom we have outlet. Can you see here? In the bottom we have outlet. Okay, so red is the inlet. Okay, and yellow is the outlet. Okay, so see, you can see here. Here temperature is T3 at the inlet to the condenser. Temperature is T3 at the outlet to the condenser. We will have temperature T4. Right? Is that okay? So let us see where this line is going. Okay, you can see this line is going. Okay, yellow line is going here. Okay, yes. Okay, and somewhere on this line, we are measuring this temperature. You can see this. Okay, so here we are measuring this temperature T3 at any point. Okay, at the outlet of the compressor, you can measure the temperature. Okay, T3. You can see this. Here I am measuring the temperature. Is that okay? At any point on the yellow line. Yes. Is that okay? Let me know. Yes. See. Respond. See, this is the compressor, right? So for compressor, see, this is the compressor as you can see. This is the compressor. For compressor, this is the inlet. Okay. Okay, this is the inlet to the compressor, you can see. So yes, inlet to the compressor, it is T1. Okay, so on the inlet here, we will measure the temperature T1. Okay, for that we have this arrangement as you can see. Okay, this is the arrangement so as to measure the temperature at the inlet to the compressor. So this will give me the value of T1 because this you can see. Okay, this is the inlet. See, you can see. Okay, you can see this. This is the inlet, right? Okay, black color is the inlet. Black color insulated. Okay, now when you go here, okay, when you see this red pipeline, okay, this is the outlet. This is the outlet of the compressor. This is the outlet of the compressor. So outlet of the compressor, okay, the temperature will be T2. So here I will measure T2, right? At outlet, I will measure the T2. Okay. Now outlet of the compressor, it is nothing but inlet to the condenser. Okay. So whatever the fluid is coming out of the compressor, it will go to the condenser. You can see it is going to the condenser. Okay. Now once, see, outlet of the compressor, it is inlet to the condenser. Right? Outlet of the compressor is inlet to the condenser. Okay. Now the fluid, okay, will come out of the condenser, okay, as indicated by yellow pipeline. Okay, so this is a yellow pipeline, okay, through which the fluid is coming out of the condenser. Can you see this yellow colored line now? Yes.
Yes, sir.
Okay.
Yes, sir.
So at the outlet of the condenser, at any point on the yellow line, I will measure T3. You can see. So here I am measuring T3. You can see. Here I am measuring T3. You can see here. Okay, so this is the arrangement so as to measure the temperature at point 3. Okay, so by using this, I will measure the temperature T3, right? Now see, after the condenser, where it is going, see here. Okay, I'm just continuously tracing this, okay, yellow colored line. After the condenser, just see this yellow line. Where it is going? It is going to the expansion device like capillary. Okay. So from the condenser, it is going to capillary. Okay. From the condenser, it is going to capillary. Okay. Now, once it is going to get out of the capillary, okay, out, all of you see here. Once it is going to get out of the capillary, okay, it will go to the evaporator. Okay. So, but before that, I will measure the temperature. So, as you can see, okay, here I will measure the temperature. Okay. So, at the outlet of the capillary, I will measure the temperature, because once it is going to get out of the capillary, it will go here. You can see here diagram. Okay. So, once it is going to get out of the capillary tube, as you can see, it is going down. Okay. So, where it is going, you can see here, this pipeline, as you can see, it is going to evaporator. I will show you that on the back. Okay. You can see this. Okay. This is a line which is coming from the capillary, and where it is going to evaporate. Right? Yes. Can you see that? Yes. It is coming from the capillary, it is going where? It is going to the evaporator. Right? Is that okay? Yes. So see, this is the evaporator. It is going to evaporator, right? And after evaporator, okay, this is the outlet. You can see this is the outlet of the evaporator. You can see. So from evaporator, okay, all of you see this. This is the outlet of the evaporator. From evaporator, okay, it will come where? It will come. Okay, you can see. Just press this. Okay, it will come again where? To the compressor. Yeah, is that okay? Yes.
Yes, sir.
Is that okay?
Yes, sir.
Okay. So here, let me recall it. Okay. This is the inlet to the. Okay. This is the inlet to the compressor, where temperature here we will measure T1. Okay. See, this is the inlet to the compressor. Okay. Inlet to the compressor, we will measure temperature T1. Okay. Now, when we see this red colored line, pipeline, okay, this is the outlet to the compressor. Okay. So at the outlet, we will measure the temperature T2. Okay. Outlet of the outlet temperature of the compressor, we will measure as a T2. Now see, outlet of the compressor, it is inlet to the condenser. Okay. So this fluid will go to the condenser now. Okay. So in condenser, it will be get cooled. Okay. So what will happen? Okay. So after the condensation process, the fluid will come out. Okay. Through the yellow line. Okay. Through the yellow line. So here the temperature is T2. Here the temperature is T2. That is at the inlet to the condenser. At the inlet to the condenser, temperature was T2. At the outlet to the condenser, temperature will be T3. Okay, so let us move ahead. Okay, to see where this line is going. Okay, so when you see, just see this part. Okay, this is a condenser. This is a condenser. As you can see, this is the condenser. Okay, so from condenser, once it is going to get out of the condenser, as you can see, okay, yellow colored line, as you can see. Okay, so we will measure the temperature at any point on the yellow colored line. Okay, we will measure the temperature at any point on the yellow color line. See, here I am measuring. Okay, so this temperature is nothing but what? Outlet of the condenser. Okay, so this will give me T3. This will give me T3. Okay, now further, okay, because this fluid, it is available at the outlet of the condenser. Now I will supply this, okay, to where? I will supply it to the capillary tube. I will supply it to the capillary tube. Okay, so for capillary tube, okay, for the capillary tube, okay, we already know the initial temperature. Okay, this is the initial temperature. As you can see, this is T3. Okay, now initial temperature for the capillary tube is T3. Outlet temperature we will measure here. As you can see, here this is the inlet to the capillary. This is the outlet to the capillary. So we will measure the temperature here T4. So T4 is the temperature at the outlet of the capillary, right? So once it is going to get out of the capillary, okay, as you can see, okay, the pipeline, okay, see from this it is going down, okay, and where it is going. So I'll just come back here, okay. So see, this is from where? This is the outlet of the capillary. So from outlet of the capillary, the fluid is going here, okay, into the evaporator. See this evaporator. So it is going to the evaporator. Okay. Now, once it is going to get out of the evaporator, you can see this line, okay, bottom pipeline. Okay, you can see this. Okay, this is the outlet of the evaporator. So this is the outlet line of the evaporator. You can see this is the outlet of the evaporator. Okay, so and from the outlet of the evaporator, you can see this is the outlet of the evaporator. Okay, see this one. This is the outlet of the evaporator. So from that, okay, the fluid is going to come. Okay, where the fluid will come? So fluid will come here. Okay, again to the compressor. Okay, so this is how the cycle will repeat. Yes, is that okay? Okay. Yes. Is that okay?
Yes, sir. Yes.
Okay. So have you understood this diagram?
Yes, sir.
Okay. So now let's see, as you can see, okay, the setup is not yet started. So I will start the setup now. Okay. I'm starting the setup. Okay. Now I started the setup. Okay. So before, see, once I've started the setup, before, okay, so before, okay, just try to measure the temperature. Okay, what is the initial temperature we have of atmospheric air? Okay, let us measure that. How much it is?
Sir, 26, sir.
Approximately 26 degrees
20.
Celsius. Can you see that? Okay. Okay, now see all of you, you can see that. Okay, we have started a machine. Okay, now see, what is the initial temperature of the air we have? Initial temperature of the air we have as 26 degrees Celsius. Okay, so we have initial temperature 26 degrees Celsius, and that temperature we will call it as T5. Okay, I'll just write down. Let us call this as T5 dash. T5 dash is initial air temperature. Okay, initial air temperature. Okay, and what value of T5 we got? 26 degrees Celsius. I just written that. Initial air temperature is 26 degrees Celsius, right? This is the initial air temperature. Now see, what I want final air temperature, because I want that air to be get cooled. I want it to be get cooled. Okay, so I want new value of T5. Okay, so I will call this as final air temperature. Final air temperature. Okay, so I need to measure this value. Okay, because see, the air, it is at initial what temperature? 26 degrees Celsius. Now why I am running this setup is I want to lower this temperature. See, this is 26. Okay, I should get its value less than 26. Okay, then only this cycle will be useful. Is that okay? Yes.
Yes, sir.
Okay, now who is going to do that? The evaporator is going to do that. What the evaporator used to do, evaporator is going to cool the surrounding air. Okay, so just see, in the surrounding of the evaporator, the air which is available, it is at what temperature? 26 degrees Celsius. The air which surrounding the evaporator, it is at a 26 degrees Celsius. That air I need to cool it. Okay, that air I need to cool it. Okay, to lower temperature. Then only this cycle. Yes, is that okay?
Yes, sir.
Okay, see, I already told you what is T1, T2, T3, T4. As you can see here in the diagram, okay, T1 Yeah. Is there any doubt? Yeah. So see, at every inlet and outlet, what we have done is we have placed the temperature sensing device. So it will give me the value of directly temperature, as I told you. Okay. Some sort of such arrangement we have made. Alright. So it will measure the temperature and it will be displayed on the screen. Right. So let us start with that. Okay. I will start with T1. Let me start with T1. Okay. Let us start with T1. Okay. See what value of T1 we have. Can you see the value? T1. T1 is the temperature. Okay. After the evaporation, what value of T1 we have? 21 degrees Celsius. Is that okay? Yes. T1 is, you can see, I'm just putting this knob. You can see this knob. Okay. I'm bringing to location 1. So it will give me the value of T1. See, this is at 1. So it will give me the value of T1. Okay. That is 21 degrees Celsius. So here I will mention, okay, T1 is equal to 21 degrees Celsius. T1 is 21 degrees Celsius, right? Yes. Okay. Similarly, let us measure T2. Let us measure T2. Okay. So I'm just putting the knob. T2. Okay. So what value of temperature T2 I'm got? You can see that's 74 degrees Celsius, right? So let us write down this value. Okay. T2. Here I will mention T2 is equal to 74 degrees Celsius. Right? T2 is how much? It is 74 degrees Celsius, right? Is that okay? Yes.
Yes,
Is that
sir.
okay? Okay. Now see. Now let us come back to here again. Okay, let us measure T3. Okay, let us measure T3. So I'll just put the knob here. Okay, T3. What value of T3 I got? You can see that 30 degrees Celsius, right? T3. I'll mention here T3. Okay, 30 degrees Celsius, right? Next. Okay, let us measure T4. T4. Yes, how much we're getting? 12 degrees Celsius, right? How much we're getting? 12 degrees Celsius, right? Is that okay? Yes.
Yes, sir. Yes.
Okay. T4, we are getting how much equal to? We are getting equal to 12 degrees Celsius.
12.
T4, we are getting equal to 12 degrees. So see, every reading, okay, I just noted down. Every reading, I just noted down, okay, directly from the setup. T1, 21, T2, 74, T3, 30 degrees Celsius, T4, 12 degrees Celsius. Okay. One more reading. What was the initial temperature we have measured? Now, what is the atmospheric temperature? It is 26 degrees Celsius. Okay. Now, I need to cool the air. Okay. Now, see all of you. All of you see here. Okay. All of you see here. See, as you can see, this is the evaporator. See, this is the evaporator, right? See, all of you see here. This is the evaporator. So this is the evaporator which is responsible to give cooling. Okay, because you will get a cooling effect where? In the evaporator. So I just shown you the side view of the evaporator. Okay. Now let us try to see, okay, its front view. Okay. So when you see the front view of it, okay, and just I request all of you to just increase your screen brightness, okay, so that you are able to see the evaporator coils. Can you see the evaporator coil now? All of you?
Yes, sir.
Yes. Okay, so now what is happening? Okay, the air is flowing in this manner. Air it is coming out of this duct. Okay, so air is coming out here like this. Okay, so see, I'm feeling cool air here because here the temperature. Okay, we have placed thermometer here. You can see thermometer. So how much temperature it is giving? Can you see that?
16.5.
Yes. How much temperature it is giving? We have the thermometer. Yes. How much temperature we are getting here? Can you see this? Yes. We are getting almost 11. Right? 11 or 12 degrees Celsius. Sorry, 16. In 16 temperature we are getting, right? 16 degrees Celsius. Is that okay? Yes?
Yes.
Yes? So we are getting how much temperature here? 16 or 17 you can call. Okay? Because see, in this region I am getting cooling, right? You can see here, in this region only I am getting cooling. Okay, so here I am getting some cooling effect here in this region. Because see, the air is flowing in this direction. So what you will observe, okay, simply, okay, if you just put your hand here and if you just observe the temperature, okay, you will find cool air here. Cool air you will find here. Okay, see, this is the setup which we have, right? This is the setup. This is the setup, right? Okay, what is the last component? This is the evaporator. This is the evaporator. So these are the tubes of the evaporator, you can see. These are the tubes of the evaporator. So if I see their front view, okay, so this is the front view of the evaporator, where inside which you can see the evaporator coils. Okay, and see, if you are physically present here, you will find that here temperature is cool. Okay, so here I am getting what? I am getting cooled air here. Cooled air I am getting here, right? So same it is indicated, okay, on this, okay, thermometer. As you can see, how much temperature I am getting? I am getting temperature here. You just see the left side scale. We are getting 16, 17, right? So this is how we are calculating, or we are measuring the temperature, okay, manually. Here we are measuring the temperature manually, right? Now for the same purpose, what we have done, okay, we have also inserted one thermocouple here, right? So as to measure it. Okay, so it will also give me the automatic, okay, without measuring that. So I'll just put the norm here, okay. So also you can see T5, how much it is giving to me, right? Can you see this? T5, yes. How much it was giving me? Somewhat 16, 17. Is that okay? See, you can see this. What is T5? Air temperature. How much air temperature I got? 17 or 16, right? 16, 17. Yes?
फ्लक्चुएट क्यों होता है सर ये?
Can you repeat it? What was the question?
So why is the temperature fluctuating?
No. Why fluctuating is not? See, still the system is not stable. Getting the point? See, when you allow this machine, okay, to get stabilized for some time, it will get stable. Now you can see. Now the temperature is stable, right? Yes. Can you see now? The temperature is stable. Yes. Now see, so same temperature, see T5, okay, T5 is the air temperature. Okay, how much we got? 17. Same value, okay, we got it here, right? With the help of simple thermometer. 17. Okay, we got the same value. Yes. Is that okay?
Yes, sir.
Okay. So see, that means what we got. Okay, what was the initial temperature? 26. Okay. Now what final temperature we got? 17 degrees Celsius. Is that okay or not? Initial temperature was 26. Now we got the temperature 17 degrees Celsius. So obviously, what happened? Okay, it is got cooled, right? It got cooled. Is that okay? Yes. It got cooled. Yes. Is that okay, all of you? Yes?
Yes, sir. Yes, sir.
See, initial temperature was 26. Now it's got decreased to 17 degrees Celsius, right? That means air gets cooled. Is that okay? Yes. Is that okay or not? Let me know.
Yes, sir. Yes.
Okay. Now see, why we are studying this is we need to calculate COP. COP. What is the formula for COP? Okay, COP we are calculating for refrigeration. COP we are calculating for refrigeration. So formula for COP, it is desired effect upon work input. Formula for desired COP will be desired effect upon work input. Okay, so desired effect is the cooling. Desired effect is the cooling, right? So our air got cooled from 26 degrees Celsius to 17 degrees Celsius. So this is a desired effect. Okay, and what is work input? Work input we have supplied, okay, in the form of compressor. So compressor is used right here. So compressor will supply what? Compressor will supply the work. Yes. Is that okay? Yes, is that okay?
Yes, sir.
Okay, now see one more parameter which is required to be here, okay, is, okay, there is one more parameter which we want to be here, okay, it is the calculation of mass flow rate. Okay, we also need to calculate the mass flow rate. We also need to calculate mass flow rate. So how to calculate mass flow rate? Okay, how to calculate mass flow rate? Okay, so for that
Sir,
we
just
have a
a quick
device
reminder.
that is called
Hello.
as.
Sir,
Is there any problem?
yes, sir, we have practical ideas.
Time is up, sir.
Is there any problem?
Sir, we have next practical.
Yes. Yeah, we'll take it shortly. Okay. We just need to measure the velocity. Okay, we need to measure the velocity of the air. Okay, which is coming out of this duct. Okay, so how to measure that? Air is coming out of that duct. Okay, we need to measure that velocity. Okay, and for that, okay, we have a device that is called as anemometer.
Sat sir is texting. He won't take anyone in meeting after 3:05.
Okay, okay. Okay, now see, okay, you can see this device. Okay, you can see this device. Okay, see this device, it is used to measure the velocity. This device, it is used to measure the velocity, right? So what we need to do is, see simply, okay, simply we need to place this device in front of this duct, okay, but you make sure that, okay, you are placing in this manner. You can see the arrow is going on the outward side, right? You can see this arrow is going on the outward side. So in this manner only we need to place, okay, and we need to place it in front of the duct, okay, so it will measure the velocity. Okay, we'll stop shortly. So which it will measure the velocity, right? So as you can see, I have shown the arrow. Okay, you can see the arrow is going on the outward side. That means air should go, okay, outward direction. As you can see, this is the flange. Okay, so air should go in a outward direction. As you can see now, yes. Is that okay? Okay, so we have a dial, okay, which will directly measure the velocity. Okay, we have a dial which will directly measure the velocity. So we got velocity 1.13 meter per second, right? This device, it is called as anemometer. This device, it is called as anemometer. Is that okay? Yes?
Yes, sir.
Simply, how you will measure the velocity? See, you can see this entire setup. Okay, I will show you this setup. This is a setup. Okay, simply we need to place this setup in front of the duct where we are getting a cooling effect. So air is flowing like this. Okay, so that's why you can see the arrow. Okay, the arrow is going on the outward side. Okay, so the air will flow in outward direction. So I will directly measure the velocity and I will write down the velocity as 1.19. Okay, 121. Okay, somewhat in that range we will get. Okay, meter per second. Is that okay? Yes. So I will also write down the velocity here. Okay, velocity is 1.19 meter per second. 1.19 meter per second. Is that okay? Yes.
Yes, sir. Yes, sir.
Okay, so with this, we will finish the today's session. Okay, and in the next session, we will proceed with the calculations. Yes.
Sir, link.
Attendance link.